Okay, we need to find the limit as x approaches 3 of the function 2 divided by the absolute value of x minus 3. So the first thing we always do is plug it in and you get 2 over 0. This tells us that there is a vertical asymptote because something over 0 is infinity. There's a vertical asymptote at x equals 3. Okay, so that much we know. But can we say that the limit is either positive infinity or negative infinity? It all depends on what's happening on either side of 3. What if they're going in opposite directions? This is negative infinity, this is positive infinity, then the limit does not exist. But if both are positive infinity or both are negative infinity, then we can write the limit as either positive infinity or negative infinity, whichever one is relevant. So now let's think about this. If I'm approaching 3 from the left, I'm thinking of a number, let's say 2.99. Remember that I'm just trying to find the sign of the infinity. That's all I care about. So I'm approaching from the left, and the function is 2 over absolute value of x minus 3. I know my answer is infinity if I approach from the left. The only question mark is what kind of infinity? Is it positive or negative? So now I'm going to think of a number close to 3 but to the left of 3, that is, let's say 2.99, and I'm going to plug it in to figure out the sign. So that is 2.99 minus 3. 2.99 minus 3 is negative. However, when you put an absolute value sign on it, it's positive. Let's do the exact same thing. Limit as x approaches 3 from the right. 2 over x minus 3. And now I know my answer is infinity, but I need to determine the sign of the infinity. So what do? Since I'm approaching 3 from the right, I look at a number to the right of 3, and a number to the right of 3 is 3.01, for example, something close to the 3 but to the right of 3. And no matter what the sign of the inside is, it's always going to be positive because we're taking the absolute value. So that is positive as well. Since these two match, the limit is positive infinity. So now let's look at another example of a similar problem. Again, I plug in a 3 and I get 1 over 0, and I know it's some sort of infinity. But the limit exists, and I can say that the limit is either positive infinity or negative infinity if I'm approaching x from the left and from the right and getting the same sign for the infinity. So let's check. So remember, I have to check both sides. So I'm going to limit x approaches 3 from the left, 1 over x minus 3. Limit x approaches 3 from the right, 1 over x minus 3. So let's see what kind of infinity. I know the answers are some sort of infinity. The only thing to determine is the sign. So if I'm looking at 3 minus, I'm looking at a number to the left of 3, like a 2.99. So 2.99 minus 3 is negative. So overall, the value of the function is negative at 2.99. As x approaches 3 from the right, I'm looking at a number to the right of 3, let's say a 3.01. I plug it in. I don't have to find the value. Remember, all I care about is the sign. So 3.01 minus 3 is positive, and 1 over a positive number is positive. So the left limit is negative infinity, the right limit is positive infinity, but they do not match. So therefore, your conclusion, and you have to show all this work to make that conclusion, is that the limit does not exist.